Hello, welcome back to On the Spot STEM, and today we'll be looking at 2018 AIMC 8 number 23, and the problem is, from a regular octagon, a triangle is formed by connecting three randomly chosen vertices of the octagon. What is the probability that at least one of these sides of the triangle is also a side of the octagon? Now this problem may seem a little daunting at first, but it's not too bad because we only have to consider two cases. The first case is that only one side of the triangle is a side of the octagon. The second case we must consider is that only two sides of the triangle are on the octagon. And obviously, three sides cannot be a case, and if you're wondering why, you can just try playing around and drawing triangles, and you see that this figure is impossible. Now, let's get started on the first case over here. First case. For the first case, what I notice is that an octagon has 8 sides. So to choose which side of the triangle I want to have in common with which side of the octagon, I have a total of 8 possibilities. I can make any of these sides be the same for both the octagon and the triangle. 8. But here's a catch. Let's say when I draw the octagon, let's say I chose this side here. Then I can only have this vertex or this vertex or this vertex or this vertex as my third vertex, because if I were to choose any of these two vertices, then I would have a triangle that has two of its sides with the two of the sides of an octagon. I only want to have exactly one side, so I can only choose one of these 4 vertices. So what I see is that when I choose one side at random and making sure that's the only side in common with the octagon, I have 4 possible vertices for the third one. So 8 times 4 gives me a total of 32 possible triangles that satisfy the first case where only one side is with the octagon. Now let's look at the second case. For the second case, what I see is that I need to have 2 sides in common, and the only way this is possible is if both of these sides are adjacent, which means they're next to each other. Because if I have a vertex right here and a triangle that I'm trying to have 2 vertices, they both have to be that are on the octagon. They both have to be next to each other. So when I have the octagon out here, and let's say I'm trying to trace it to see how many pairs of these adjacent sides I have, I see that I have 1, 2, 3, 4, 5, 6, 7, and 8. So I have 8 pairs of these possible, next to each other adjacent sides of a triangle that coincide or overlap with the octagon. So I have 8 cases here. Now here's the thing. Once I choose these two sides right here, let's say I choose this, I'll bolden it so it's obvious. Let's say I choose this side right here. Then I don't even need to worry about a third side because I already see 1, 2, and 3 vertices here. And when I combine them, voila, I have a triangle that has exactly 2 sides that on the 2 sides of the octagon. So what I see here is the second case only has 8 possible combinations, which means the total possible combinations I have, in terms of the probability of cases that I want, I have 8 plus 32 equals 40 possible triangles that I have that satisfy a condition. Now the question asks for a probability. And probability, as we know, is the desired outcomes that we want divided by the total possible number of outcomes. 40 is the desired outcome we want. But the question is, what is the total number of possible outcomes? Well, the total number of possible outcomes on the denominator is 8 choose 3. Now, this notation may be a little off. If you're not sure about this notation, I suggest you to look at one of our other videos that we'll have posted soon. Or you can just even look up combinations on Google. So basically what 8 choose 3 here says is how many ways can I choose 3 things from a group of 8? Or in this scenario, how many ways can I choose 3 different edges from these 8 edges we have, the 3 different vertices from, these 3 vertices I have from the 8 vertices I have in total, such that I can make a triangle, because all I need is 3 vertices to make this triangle. And I see 8 choose 3 evaluates to be 56. So I have 40 over 56, and this simplifies to 5 over 7. Now when we look at our original answer choices, we look to see if that's one of the answer choices. And indeed it is, because 5 over 7 is D, and that is the correct answer to this problem.